everyone, I'm Samson Joseph, here to explain the fourth experiment in the data science ecosystem lab, which is exploratory data analysis. So I'm coming under batch one, so I'm using the EMP EDA dataset. So first I imported the dataset. So in the first question, it's saying to remove the irrelevant columns from the senior manager and display top five rows. So for that, we are using drop function, and the column we mentioned is senior management. So it will drop all the columns with the senior management, and in place will directly permanently update in the main dataset only. And to show the top five rows, we use df.head. Uh, for the second question, we have to remove the duplicate rows and display the shape of the data. So similar to the previous question, we are using drop underscore duplicates. It will automatically remove all the duplicates and in place will permanently update the original data set. And to show the row number of rows and columns, we are using df.shape. As you can see, after removing all the rows, there are 24 rows and 8 columns. In the third question, we have to rename the column bonus to incentive and display the top 5 rows. So to rename the column, we have used the rename function. In that, we use we are replacing bonus column to incentive column, and in place will directly affect the original data set. And df.head will display the top five rows. As you can see, the bonus column has been replaced to incentive. In the fourth question, we have to drop all the missing values row-wise and display the shape of the data. Since the question is asking to remove all the values row-wise, so we are using drop any function which will automatically drop all the none values. And in the axis, we are adding 0 because we have to delete row-wise. In place will automatically affect the original, permanently affect the original data set. Then df will shape will show the rows and columns after deletion. So as you can see now, previously there were 24 rows and 8 columns. Now after removing the none value, it's 22 rows and 8 columns. In the fifth question, we have to calculate the central tendency measure for experience. So central tendency measures is nothing but mean, median, and mode. So for those three, we have used the functions dot mean, dot median, and dot mode. After calculating the mean, median, mode, we just printed it. As you can see, the mean, median, mode for the experience column is this. The next question is asking to calculate the variability measure for experience. So variability measure is nothing but the range, variance, and standard deviation. The range is experience age. To calculate that, we have to first get the maximum value from the experience column and minimum value from the experience column and subtract it. By doing this, we will get the experience range. But for variance and standard deviation, we are just using functions variance, VAR, and SGD. And to calculate the IQR, we have used quantile function. So so we have to get first. There are three quantiles. So first we have used dot quantiles 0.25. It will give the first quantile, which is 25%, and we have to get the third quantile, which is 0.75%, and we have to subtract it to get the IQ, and then we'll print it. As you can see, these are the calculated values. The seventh question is we have to calculate the IQR using quantiles. So similar to the previous question, first we have to create the we have to get the first quantile by using dot quantile 0.25, which is 25%. Then the third quantile 0.75%. Then to get the IQR, we need Q3 minus Q1. In the next question, we have to calculate the zero score and for experience and discipline. So to to calculate the zero score, first we imported the SciPy function, SciPy library, SciPy.stat, as it will help to get the z score value easily. So first we imported that, and to calculate the z-score, we are using start.z-score. It will automatically get the z-score values. As you can see in the table, we'll get the experience underscore z-score. In the next question, we have to plot the heat map using correlation. The heat map should be between salary, experience, and age. So first, what we did is we created an array with selected columns, salary, experience, and age. Then we use correlation function, so that it will get the correlation from the three columns and store it in correlation matrix. Then we have to plot the heat map. For plotting the heat map, I have used Seaborn library, as it will help us in creating the heat map. Uh, so yeah, so to create the heat map, we have used sns.heatmap and correlation the column what we have to create. Then this will create the heat map for the three correlated columns of between these three. For the 10th question, we have to add two new rows at the end of the data frame and display the last five rows. For that, first we created two new rows with all the details as first name, gender, table, and experience, etc. Added those values and created another row, first name, gender, salary, etc. Then what we did is concat those two rows in the original dataset, and at the end we printed df.date. It shows the last two columns, as you can see. Uh, the last two rows are the ones we just added. The next question, we have to replace the none values in salary, mean salary, and display the last five. So for that, first we need to calculate the mean from the salary column. So we are using mean function. Then we created a separate column as salary. So we are updating the salary column and filling all the none values in that with the mean. As you can see, but then I printed the last five value rows. In the next question, we have to detect the outliners in the experience with box plot. So for that, first we are we're doing a box plot with the column experience, and as you can see by using plt.boxplot, and for this we are using matplotlib function. So this will create a box plot which will be showing the outliners in experience. So in the next question, we have to remove the outliners using IQR. So first we created a copy data frame, and then we have to find the first and third quantile. To find that, we are using dot quantile 0.25, which is the first quantile, then 0.75, which is the third quantile. Then to find the IQR, we just subtracted the third quantile with the first one. After finding the IQR, with the help of IQR, we'll find the lower and upper bound. So to find the lower bound, Q1 minus 1.5 into IQR, and similarly up the upper bound also. Then after finding the upper and lower bound, we just segregated the experience column with the lower and upper bound. And the new IQR is the subtraction from the third quantile and the first quantile. So, and for that we created a box plot using the matplotlib. First we imported matplotlib library and used box plot function. As you can see, the new IQR is 8 and it's the box plot. In the next question, we have to remove the all outliners using z-score. So again, we created a copy data frame and we use NumPy library for this and use absolute function to calculate the z-score from experience column, then segregated the experience column as z is less than 3, and then again calculated the z-score so added the z-score in the new column experience z-score, Then we printed the first, so as you can see, the head function will print the top five values, and the new z-score is printed. And with those new z-score, we created a box plot. As you can see, this is the box plot for the experiment. In the last question, we have to drop the last two rows added in a data frame. So for this, we are just using the drop function. We have to drop, and since we have to delete the last two rows, we are using df.tail.index. It will automatically remove the last two rows. Here ends the fourth experiment. Thank you.